Welcome to the webinar. You have entered as...
Hello and welcome. I'm Ray Stahl, and I will be the monitor for today's Digital Metrology Standards Consortium presentation for September 2021. Today's presentation is by Semantic, and it's Planning Your Model-Based Journey. Today's presenters from Semantic are Jesse Zahner and Ross Snyder. Can you go to the next slide, please? We have a few housekeeping rules that we'd like to review with you. You'll be in listen-only mode, but during the presentation, if you have questions, if you can click on the panel called questions, we'll collect those, and we have a Q&A section at the end of the meeting, at the end of the presentation today, and we will go through those presentations. Don't worry about taking notes. By tomorrow, you'll receive a link for this video presentation. Next slide. So without further ado, let me introduce Jesse and Ross.
Awesome. Well, thank you very much, Ray. As he said, I'm Jesse Zahner. I'm a product specialist here at Sigmetrix, and I have a relatively decent history in MBE, MBD, which is what we're here to talk about along with QIF. And my associate that's here with me, Ross Snyder, I'll go ahead and let him introduce himself.
Hi everybody, my name is Ross Snyder. I'm an application engineer for Sigmetrix, and I'll be piloting the hands-on portion of our demo today.
Yeah, Ross is the brains behind the software and the application and its uses. So look forward to a little bit of a demo there from him later on here. So Absolutely. Let's go ahead and get started. So I'm excited to be able to talk to you guys today about model-based enterprise and about model-based definition. As it relates to QIF, MBE, and MBD are huge, especially when we're talking about advancing the technology that we have today into applications beyond just what we have in the model versus what we have outside of the model. So the state of the industry, as we're looking at it in 2021, and actually I just remembered we should probably turn off our webcam so that we have better bandwidth. So I'm gonna pop that off real quick, just so that way during the demo we don't have any problems. So back to the state of the industry that we have here. When we're talking about drawings versus models, in industry, we tend to see that drawings are still prevailing as the master sources of data. And what that means is that the drawings are really the authoritative source when it comes to verifying information for the product. So 3D CAD files are up and coming for a lot of companies, but in some industries, such as like aerospace, some defense, some automotive, you really see a push to get those 3D CAD files as the master definition for that information, because that information can be shared and used downstream in a way that a physical drawing cannot. You know, physical drawings are very limited in their capacity to be able to share information for people that are not experts with that. So models can be used to display information in a variety of ways, and that's one of the things we're going to talk about today. So go ahead and advance us on here. Model-based enterprise is a strategy. It's a business strategy. It's not one single thing. It is really about being able to take this three-dimensional product and utilize information that would typically be stored alongside it or inside of it or with it in all different facets of your industry or your company. So we're looking at being able to understand how your production environment is going to be able to read instructions for manufacturing the product. We're looking at analyses to understand your dimensions, your tolerances, your FEA, which is your simulation. We're looking at understanding the information that's being kicked back out of your machines in production to see if there's anything going wrong, if anything could be improved, and then we want things to be readable. There needs to be information that can be shared, and that's part of this digital thread that you're seeing in the center there, is being able to take information from one end of a product's life cycle to the other and make it so that that information is not only readable, but usable by all people in that specific industry or in that company. You want to be able to share that information as it goes downstream. So go ahead and click on over to the next one. And one of the goals that you can have for model-based enterprise is having high quality data, not only so that it's easily accessible, not only so that people can look at that information and click through a bunch of different tabs and notes and everything that may have been stored there, but so that it's easily accessible and so that you're reducing the amount of time being spent on rework, redoing work, regathering information, putting things into the system. You want to improve communication throughout your life cycle. And that's one of the main goals of QIF, is being able to maintain information going from one end of a product's life cycle to the other, being able to string that information along. It fits right into the model-based enterprise formula of being able to structure your information in a way that makes sense to the users and to the people that are going to be accessing this information, maybe outside of your organization, further along in the product lifecycle, or even upfront, people that are doing the designing. So let's go on to the next one here. As you can see on this slide, there's just a bunch of bubbles. And one thing that I like to try to get across is that model-based enterprise is not one single thing. You often hear MBE, MBD. You hear those two things side by side. You hear model-based enterprise and model-based definition or model-based design. And while model-based definition or design is one facet of a model-based enterprise, it does not make up the entire umbrella. A model-based enterprise is a series of MBX or model-based activities that go into this strategy, this organizational idea of being able to get your information structured. As you move into taking advantage of a model-based enterprise, you're going to have all of these different activities that are inside of your organization, whether it's in design, engineering, inspection, manufacturing, after the fact, when you're doing an analysis or you're worrying about how to break down the product. There should be information that can be shared along all of those different chains inside of your specific organization, and those model-based activities all fit together under this model-based enterprise. So let's head on to the next slide here and talk about what is a model-based enterprise exactly. I mean, I've given you some definitions here. I've talked to you about how it works and some of the stuff that goes inside of it, but really it's an opportunity to take advantage of your 3D data and realize the benefits that that data can provide you downstream. So when you're utilizing those model-based activities that occur throughout the life cycle of a specific product or a part, then you're looking at being able to understand the information, reuse the information, optimize that information. You're looking at being able to take the data that you're gathering and share it with people in ways that they can understand. You know, not everybody in your company is going to be a CAD expert. You can't take, from a designer, you can't take a 3D model with all of your PMI or GD&T on it and take it to a salesperson and say, hey, you need to understand this part and you need to go tell everybody why it's important to have these little numbers and these words and these lines on this part and why we're better for having that there. That salesperson's not going to understand because that's not their job. They don't have that background. They don't have that information. So you need to be able to take what's there and the opportunities that are being presented by accessing that information early and present it to them in a way that they can take and forward on. All users inside of a model-based enterprise need to be able to benefit from the information that you're gathering and you're using as part of that product's life cycle. And that's one of the main goals, is to be able to provide that communication throughout the life cycle. Let's head on to the next slide here. Yep, so product manufacturing information, when I was talking about those numbers, when I was talking about those letters and those lines, we're talking about PMI. And PMI is known by many different names. Some people call it annotations, some people call it GD&T, some people call it tolerances, product information. It really depends on where you're at in industry and the terms that make sense to you. But what it really comes down to is it's information that is relevant to the manufacturing of a product. It's information that gets put on there to tell somebody how something needs to get made and why those specific surfaces or those features are important and why they need to be controlled when you're making them. So these dimensions, these notes, tolerances, all of that stuff is tied together in a way with the 3D geometry to make sense of the product definition when you're going to be manufacturing it on the line. So there are many different things that you can do with this information. And as a matter of fact, Ross is going to get into that with his demo here. He's going to explain a little bit of how you get this information on there and why things show up a specific way. But what's important to know is that this GD&T is very important. So let's head on to the next slide here and kind of answer that question. Why is GD&T important for model-based enterprise? Why does it matter? Why is GD&T important for QIF? Is another question that's relevant here. So it provides multiple types of information. If we're talking about presentation information, we're talking about information that is presented to you as the user. It's those letters, those numbers, those words that are showing up, things that you can read, things that you can access. If we're talking about the representation forms of information, it's how that geometry is being confined in the system. It's how it's being constrained. It's how those features are relating to one another, the mathematical backend, the metadata that's being stored inside of that product. When we're talking about presentation and representation forms of information, we're talking about your GD&T, your analyses, your metadata, everything that relates to that product. And those model-based activities all take advantage of this information. When we're using GD&T correctly inside of the model, we are supporting that model-based definition, and we're allowing our downstream processes to take advantage of that information that is inside of the model that's being stored there. So when we're not utilizing GD&T, it can actually hamstring your progress towards MBD or MBE. And that's a problem, because when you're trying to incorporate a model-based enterprise into your organization or as a part of your day-to-day, you want to make sure that you're utilizing all the information that you can. So understanding how GD&T can fit into the role of your product and into the role of your organization is important, but it's also not only important to your company, it should be important downstream as well, and to all of the software that could possibly utilize that information along the way. So let's head on to the next one here and talk about a schema. And I think, Ross, we're getting a little background noise, or Ray or somebody, I don't know who that is. But the MBD schema, and one of the things that I want to kind of instill in you today as we're going forward and talking about this GD&T and the information, is the way that it's being put together. So a schema is really just a way to organize information. It's a way to couple that data with a file scheme or an organizational scheme that allows you to understand how that data is being stored, where it's being stored, how it can be utilized, why it's important. All of these questions that you may have should be able to be answered by your schema. And one of the ways that you can use this schema is to be able to store your GD&T, to be able to store your models, your specific model views, your different definitions, your different understandings of a product in a way that somebody that needs to come in and navigate the part to gather specific information could use. They could just come in and click on what they need to, or they could access a document that you've created that contains that model-based definition information for them to utilize downstream. So let's head on into the QIF discussion here. When we're talking about quality information framework, which a lot of you came here today to get a little bit more of an understanding of QIF and how it relates to MBE, MBD, we're talking about this framework. We're talking about this, I'm going to call it a web of information that is all tied together at the center by understanding your product, understanding your part, and then noticing information and gathering information that's important to you and important to your product throughout the life cycle. QIF provides a way to provide identifiers to all of that information, to track your information from one stage of the life cycle to the next, from one software to the next, from one CAD system to the next. QIF really strives to be this in-between, this, I'm going to say, neutral step that allows you to store information in a way that it becomes viable in all of these different facets of the product's life cycle. When we're talking about this information that may be important to you, we're talking about your measurement information, your quality information, your PMI, your geometry, understanding the instructions that go along with it, any notes or testimonials that have been given along the way. Having that information available throughout the entire life cycle of the product and throughout the digital thread of that product's plan is paramount. It's completely necessary to be able to understand fully how that product is going to benefit your company. So one of the things that we want to talk about with you today is specifically the MBD portion of that, and even more specifically, the GD&T portion of that, why it's important and how it relates to your geometry, and then how to get it in there as well. So if we go on to the next slide here, this is where I will let Ross come in and take over and talk to you about GD&T Advisor and GD&T in general. So Ross, take it away.
Thanks, Jesse. So this is one of the slides that we typically use in one of our presentations for sales things, but I'm going to take a step back a little bit and just kind of look at this a little bit broader scenario. As Jesse was saying, it's really important to introduce a high level of information that is of a quality and accuracy that is useful down the entire stream of your product lifecycle. Now, by doing this, we at Sigmetrix have a couple different software options that we use. That this is a very helpful way of handling our data as well. So by introducing this information with, in this particular situation, GD&T Advisor, it allows us to get users that may not be perfect subject matter experts in adding GD&T into the process and adding this information accurately as early as possible, so that it maintains itself to the standards that we need to be adhering to, and the information stays with the product throughout the entire life cycle. Now, we also have other products that we use downstream. For instance, we have a program called CETOL that does tolerance analysis. And that program, while it doesn't require this information to be functional, a perfect example of where this can be really a huge benefit for companies is that by maintaining this information earlier in the process with GD&T Advisor, that actually feeds a lot of that information directly into a product like CETOL, so that it cuts down on the amount of information that you have to manually enter when you go through to use that. So it's an efficiency thing, it's an accuracy thing, and let's go through and see how this particular tool that we have to offer works into the overall premise of QIF and maintaining this information throughout the life cycle of the product. So what we're going to be looking at today here is this is our caster wheel. It's a demo model that we use for a couple different events and expos and things like that. Something nice and simplistic that most of you have seen either in the shop on moving carts, or even just shopping around at your local grocery store. I promise this one doesn't squeak or rattle. What we're going to do is we're going to take this support piece here, and we're going to add the necessary GD&T callouts for this particular part quickly, efficiently, and with the guidance of this software, to demonstrate how even entry-level and beginner users into this program are able to, if they're able to enter this information accurately, they can be part of the process, and it can be beneficial and used all the way downstream and even partially back again. So with that, give me 2 seconds to switch over here to our Creo window here. Jesse, you guys, can everyone see my screen okay?
It looks good to me.
Awesome, fantastic. So what everyone's looking at right now is a standard window in this particular instance, Creo. And what we have is our GD&T Advisor tool installed here, and it's just a plugin. Just to give you a brief run through of kind of what we're looking at here, just our model window, which should look fairly familiar for any of you in CAD design. Up here, we've got a ribbon of tools that are specific to our GD&T Advisor, our feature tree. As we start interfacing and defining our GD&T, this tree will fill out much similarly to a model tree that you would see in, CAD, Inventor, Creo, things like that. Down here, though, is going to be really where we're going to put a lot of focus on. This is our advisor tree. And this is where the GD&T Advisor comes into play to help you along and guide you through the process of adding these callouts so that they adhere to our ASME standards, they're entered correctly, and they play nice with the part so that we can count on the information downstream. So information regarding anything that we need to focus on, anything that we need to do or missed, or any errors or incorrect bits that we've put in here are all going to show up in this advisor tree, and we'll be referring to this throughout most of this little demonstration. So to start out, like we talked about, what we're going to do is we're going to completely dimension this with GD&T so that we have the appropriate callouts for ourselves downstream. What we need to pay attention to here is our advisor tree is telling us that not all of our degrees of freedom are constrained. So that's one of the things that we're going to need to address to make sure that this is done properly. And one or more of the surfaces that we have are unconstrained as well. Now, to start out with, let's get our datums situated. So we're going to start and tolerance this top surface here and hit OK. Now, you can see that our toolbar has changed as we're trying to identify all the different information that we're going to need for this particular GD&T callout. You can see over here that it's already trying to make it datum A. If that's something that we didn't want, that's simply an uncheck here to decide whether or not we want to actually use this particular callout for datum A. Over here is where we're going to be able to define our geometric characteristics. So your straightness, your flatness, circularity. You can see that a lot of these here are grayed out. They're not available to us because they aren't appropriate callouts for this particular GD&T callout that we're putting in place. Now you can see these two green ones here. Those are available to us, and they are. So the profile of a surface and flatness are available, but you can see there's a little asterisk right here. The program is telling us, based on the fact that there is no other informational callouts that we have to work with here, that flatness is probably the most appropriate callout for this particular situation. So we'll go ahead and go with the recommendation of the software. Go ahead and enter just a 0.1 here for a tolerance, and you can see that now that we've filled out the basics, it's going to allow us to move forward. And we'll go ahead and hit the checkbox here. And now our datum A has been defined with that GD&T callout appropriately inserted and referencing the part right there. Very easy, very user-friendly. Now you can see that our advisor tree down here has changed a little bit. Now our messages are still there that we're trying to address, our degrees of freedom and our unconstrained surfaces. So we're still working towards that, so there's more to do. But we've got this new informational bulletin. It's not a warning or anything that's a problem. It's just pointing out that this new datum reference that we've put in here is not being used for anything. So let's go ahead and add another tolerance in here and see if we can't take care of some of these things that we're trying to check the boxes for. So we'll go ahead and add our callout for this whole next. Now, when we do this, you can see that the callout's a little different because it's more of a whole dimensional callout. We've got some information to work with here. Now, again, as we click on our geometric characteristics dropdown, more of these are available to us. We can see that there are some different options now that we've inserted our datum A. This isn't the only callout we've got going on. Angularity and perpendicularity are both recommended to us, perpendicularity being the one that it recommends the most. But what we'll go ahead and do is we'll go with this, add our dimension here, and now we have to make sure that we tell it whether or not we want to use this as a default for regardless of feature size, that RFS, which is where we are going to leave it. Alternatively, we could put this in as maximum material condition or minimum material or least material condition if that is something that we needed for our particular circumstance. And you can see that automatically it's shifted to inserting datum B instead of datum A because we don't have A, B, and C datums yet. We want to leave that in there and that'll be good to go. But one of the things that we do want to do is I want more than one refinement on this particular GD&T callout. We can drop that in right here and put a second one. Now, as we click on this, you can see that some completely different recommendations are being made to us. So now we can choose things like circularity and cylindricity. We're going to go with cylindricity because it's the highest recommendation from the program as it reads into our model. However, something I'd like to point out is as you hover it, you can see these messages pop up. It will tell you why some of the less recommended options are potentially not good options. So for instance, parallelism here, it's not compatible with our DRFs right now. Or for instance, angularity, it may over constrain the call that we're trying to use. So we'll stick with cylindricity. And we're going to put this in here as a 0.5. And then now that we've filled that out, we'll go ahead and hit the checkbox. Great. So now that we've called that out, that's all dropped in there. And hold on. We're back at our advisor tree here again. And you can see, man, now we've got this red X. Well, that doesn't look good. Let's figure out what's going on. The form tolerance must be smaller than the specified size tolerance. Now, for some of you that are very familiar with using GD&T, that may be kind of a no-brainer for fixing. But we can see as we select this here, it'll highlight where the issue is in our feature tree. And we can actually right-click and go to more help. And there's a ton of built-in help information to help us untangle this. This is going to help us identify, okay, what does this particular message mean to us? And importantly, how do we fix it? So again, the software tool that we're trying to bolster the concept here that getting entry-level users or intermediate users into being able to do this information insert this information accurately into our data so that it can be used downstream is a benefit to everybody in the process. As long as it's guided and done correctly, then it can be counted on later and it's available to us. So we know we have to adjust that sizing. Let's go ahead and close out our little help window here. And then we're going to go in and edit that dimension. And so we can see, like it was trying to tell us up here, that plus or minus, this 0.5 does not fit into that window we defined. So we have to correct that. And we'll go back to that 0.1 we're using for everything. Check that box. Now our advisor is telling us, you know what? You fixed it. You're good to go. So let's go ahead and do that same process for the second hole here. Tolerance this feature, hit OK. We're going to leave this at 0.1 and RFS like we were doing. This is going to be our datum C. That'll be great. And we also, on this one, want another callout. So we're going to put this one at cylindricity to match the other hole because that's what's important for our particular situation. And again, you can see that some different options have popped up, and it's going to tell us why or why not they may be useful or not useful for our particular scenario. Again, guiding the users so that we can make sure that according to the specifications, we're inserting this correctly and accurately to the best of our abilities. So we're going to go ahead and insert 0.1 in here. Hit OK. Now we've got that third call out. And now we've gotten all of the features that we want to identify in this particular surface are set. And we have an A, B, and C datum reference. But we know that this is going to be mating with a bushing and another surface. So let's make sure that we call those out too, because those are important features for us to control. So go ahead, call this out here. And one of the things that you can also pay attention to is if for some reason you do want to adjust the tolerancing dimensions directly when you make this call out, that is also available to us up here at the top. We're going to leave them alone for now, but that is available. And we can go ahead and add 0.1 and RFS and hit OK. And now we'll go ahead and hit that other surface that we know is important and is going to mate with some things on our overall assembly. That one, we can see that profile of a surface, which makes sense. It's a flat surface that we're trying to control here. And you can see that automatically these references for our DRFs are included. Now, something else to pay attention to is when we put in our last one of the targets that we had here went away. So now our degrees of freedom are controlled. We're still trying to make sure that all of our surfaces are controlled on this particular part for us. So we'll enter this and hopefully that takes care of it. Well, we've controlled all the important parts that we have here. We know that all of these things are critical. We've got them controlled, but for some reason we still have this message. Man, that's a real head scratcher. Fortunately, we also have a tool that's going to make things easy for you to identify, man, what did I miss? I thought I had everything dimensioned in here appropriately. So if we click this show and hide constraint state, this will actually paint our part up here and give us a little legend of whether things are in the green, fully constrained, yellow, partially constrained, which we don't have any examples of on here, or in this particular situation, which looks like where our problem lies, completely unconstrained. All of these additional surfaces are unconstrained. Now, in the grand scheme of things, is that maybe a problem, maybe not a problem? That depends on your particular usage case. However, we'll go ahead and we'll close out of that, and we can address that notice here and tick all the boxes so we can move forward on this. I'd like to go ahead and put an overall surface call out on this so that it controls all those additional surfaces just within a certain degree. If we go into edit properties, and we go to properties and notes, we can actually add a general profile tolerance to the overall part for anything that's not being specifically defined. If we click on that, we can enter a dimension for it. And now you can see popping up right here, all formatted correctly for our ASME standards. We have our overall surface tolerance. And if we go back to that tool, we can see that all of these different surfaces now, in addition to the ones that we specifically defined, have all been controlled by that surface callout, and that's taking care of our issues over here. So now our parts, all of our critical areas are completely constrained with our GD&T. The advisor tree is happy, and I, as a new user, am confident that that information was formatted correctly so that my guys on the floor aren't going to yell at me in about 2 days when they finally see these things in print. So moving on from that, we can see that using tools like this can be a really quick and easy way to get users of multiple different ability levels to be able to enter this information or interact with this information, whether it's initially designed and put into a new part, or you're making modifications or corrections based on feedback that you're receiving from the floor. That can all be done by entering things in a friendly and guided environment so that it can be depended on later. It's able to be talked to because it's using a standardized format, and something like this would be a perfect data entry point to feed into your QIF environment, or so that other programs downstream can communicate and interact with its data. And with that wraps up the little hands-on show that we've got for the demonstration. So Jesse, I'll go ahead and hand this back to you, and I'll pull up the rest of our presentation and we can move forward.
Awesome. Thank you very much, Ross. Good demo. And what you saw there with Ross was really the ability to input that information in a model, regardless of your ability level. He showed the help situation that you had there, being able to right-click and get tutorials and get information. There's video tutorials in there. And once again, that tool is available right inside of PTC Creo. It's also available as a standalone. And we're not here to make a sales pitch. We're not here to sell you on the software. We're here to tell you about why that's information that is necessary for you to utilize inside of QIF and inside of MBD, MBE. And one of the reasons that you would want to have quality information in there is so that downstream it's able to be utilized, even upstream. You know, information doesn't only flow in one direction. When you put that in there, you may be taking that design back to the very helm of the ship and having to redo everything and go through multiple different iterations. So having that quality information there from the start is a way to make sure that that rework doesn't need to be done and that you're saving yourself that time and effort later on. So we're on this conclusion slide right now where I'm going to go over, just what I discussed briefly and then touch on a couple more topics here. But we have a few poll items that I want to pull up just to gather some data from the audience that we have here today. So the first poll that I'm going to activate for you guys is going to ask you how familiar you are with MBE, MBD. So Ray, if you want to go ahead and stick that up there. So you guys can click on an answer and.
Yeah, click on the answer. We're going to give you about 10, 15 seconds here to respond, and then we'll show you the results.
And this is just a good way to gauge the understanding of the audience that we're working with. So that way, as we go into the final conclusions here in the Q&A, I know what level I can speak to this information at and kind of what things I should target.
All right, about 10 seconds more. All right, I'm closing the poll. And here's your results.
Okay, so we don't have anybody in the crowd today that is not at all familiar. We have at least some familiarity all the way up to expert level, which is great. Getting people in here that understand MBE, MBD, and are excited to learn more. The second poll that I want to get up for you is related specifically to your model or your master file. Understanding what kind of information you're utilizing in your organization. Do you have a master model? Do you have a master drawing? Are your model and your drawing the master in sort of a hybrid format? These are questions that we like to ask because it gives us an understanding of how this information flows inside of your organization.
And again, about 10, 15 seconds more, and we'll close the poll. And I'll be closing the poll.
Okay, yeah, that's about what I expected. Drawing as the master is the definitely the front runner here, and that's notorious. I mean, that's well known because drawings have been in use for I mean forever, right? Models are something that you only take advantage of if you have the technology, and you have to train your staff, and you have to understand what goes into the model, and all of the organization, and the file schema, and the MBD, and the MBE, and blah 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 blah. So it makes sense that the drawing is the master for the majority of you. But I am happy to see that model and drawing are master is 33 and model is master is 23, because that means that there's utilization in both of those. And as we're moving forward, I would like to see model being the master for all of those. But having model and the drawing as the master is typical as we see that transition into a model-based enterprise. So this third poll that we want to ask you before we get into the conclusion here is about QIF. So we went over the quality information framework a little bit earlier, talking about how it's this neutral idea of being able to get information from one side of a product to the other. We want to understand what kind of QIF utilization you have in place. And this doesn't mean that you have to have, full-on adopted QIF. You don't have to have the full library downloaded and implemented in a full workflow. But what kind of utilization do you have in maintaining that sort of information throughout your organization? So what kind of QIF do you experience?
And we'll give about 5 more seconds. I'll be closing the poll.
Okay. Yeah. So not having QIF utilization, being the front runner, makes sense because it's new. It's something that it's been around for a little bit. I shouldn't say that it's relatively completely new, but it's something that you have to be in a mature state of technology and of MBE, MBD to be able to take full advantage of. So 10% QIF centric, that is a lot higher than I expected it to be. That means that at least 5 of you that are out there right now are, and that maybe in 5 separate organizations, are utilizing QIF completely, which is fan-freaking-tastic. So kudos to you. Okay, we can go ahead and close the poll out. So one of the things that I wanted to mention is that QIF, as it relates to GD&T, is important for understanding that information from start to finish, yes, but it's also something that you can't just utilize. You can't just turn it on. It's like MBE. It's not a switch that you can flip. It is the implementation that takes time and effort. I would say that it's another one of those model-based activities that fits into a model-based enterprise, but QIF doesn't have to be focused around the model. It can be focused around that quality information, that inspection data, other forms of information that supplement the model that can be used to carry that information from one end of your product's lifecycle to the other. So QIF is something that you really get into adopting as you move into an MBE, MBD formula and get a better understanding of your product. So it's good to see that we have some utilization today, but for those of you that don't utilize QIF, don't be disheartened. It's something that as your maturity level grows with MBE, MBD, it's the next logical step, is building that pathway for that information. What you saw today from us with GD&T Advisor was a way to be able to get that quality GD&T information on your part. And not only is it on your part, it's guiding you through the process of putting it there and explaining to you why that information is the way that it is through the help tutorials. So that's important as a train as you go sort of step. And once again, that's available with PTC Creo and standalone. And there's tons of options out there to be able to get training on GD&T, MBE, MBD. And one thing that I want to emphasize is that no matter how you're absorbing this knowledge, whether it's attending webinars, whether it's purchasing formal training from some vendor or another, you need to be constantly growing in your understanding of MBE, MBD, and QIF as it becomes a bigger factor going forward, because it will only help you internally in being able to start those conversations and championing those efforts and getting things going. Currently today at Sigmetrix, we have work being done to determine how QIF can actually allow us to get this original analysis data that we have for the part updated with measurement data from produced parts that are on the floor. So there's this flow of information that we're working on to be able to get data from the floor, from the production floor, back into the design environment to automatically and sustainably update your parts, so that way you can get those live interactions on the go. So that's one way that we are utilizing QIF today. And I just really hope that going forward, as you guys continue to go to these coffee chats, as you continue to be involved with DMSC, you continue to grow your understanding and reach out to companies that are working with QIF to get a better understanding of how they're using it, and then hopefully incorporate those ideas into your organization so that as an industry, as multiple industries, we can all grow together. So thank you for your time today. And it was great speaking with all of you. So I don't think there's anything else left here.
No, we have Q&A.
We have the Q&A, and we have
a few questions that have been building here, so we'd like to try to address them, if you don't mind. First question is GD&T Advisor. Does it come for SolidWorks, and is it updated to the latest ANSI Y14.5 2018?
So I can take this one, Jesse. So yes, it works with the up-to-date standards. Right now, the only available versions that we have of GD&T Advisor are for Creo, as you saw today, and this technology is also integrated with Autodesk Inventor as well. But as a company that, you know, we're learning and growing with the rest of you in industry, a lot of the technology that helps support things like our downstream production are all based off of feedback that we get from customers and people's necessitated questions and desires for new software. So if there's drive for stuff that we don't have right now, it's driven a couple of our developments already. I wouldn't put it past us to put something else in place as well.
Okay, thank you. Next one is to Jesse. I think I understand your discussion on the model-based enterprise definitions. On your bubble slide, why is the model-based enterprise shown as a standalone center bubble and not a bubble that contains all the other MBXs and other bubbles? And then the compliment, really good view. Thanks.
Awesome. You want to go ahead and tab back to that slide there, Ross? And
yeah,
we'll just
absolutely. I can do that. Oh, and also I didn't realize there was actually a question slide. I'll leave it there.
There we go. So this view that you're seeing here, when I was talking about model-based enterprise, it is an umbrella term that contains all of these model-based activities. However, model-based enterprise, once again, is a business strategy. It's an organizational attitude at which you're adopting, facilitating all of this information and kind of combining it all and utilizing it for the full product lifecycle. Now, model-based enterprise would typically encompass all of these. You're right, there should be a big bubble that contains all of them. However, a lot of organizations today that would not classify themselves as model-based enterprise or model-based definition centric do still utilize model-based activities, whether they realize it or not. Maybe they have their model-based design. They're not drafting everything on 2D paper, they're just doing model-based design. So that's one facet. Or maybe there's another organization that's doing model-based inspection, where they're running simulations on their products and they're getting that information to use, but they're not utilizing all of these different model-based activities together to form this model-based enterprise approach. So the reason that they're separated here and that you're seeing all of these different MBX activities as separate is because they are separate activities. They can be utilized separately, and you can see benefits from using the model in any of these applications. However, with model-based enterprise, the goal is to take all of that information that you're utilizing from those model-based activities and bring it together and use it in a way that can be communicated both upstream and downstream to all users. So I hope that answers your question.
Good. Next question. Is the general profile tolerance semantically linked to the Creo model? Parentheses, can I query the call out in notes and see the associated surfaces?
I'm sorry, so could you repeat the question for me?
Yeah, I will. Is the general profile tolerance semantically linked to the Creo model? In other words, can I query the call out in notes and see the associated surface?
It is not, unfortunately.
You just saw a little pop-up from Steven there too. Steven must be
I
on the
sure
call
did.
today.
Yes, Steven's answering my questions before me before I have a chance to. I love it. Where we handle this stuff as a team. I love that.
And if
So
you
then,
have extra information about that, if you have additional questions about that or you want to learn more, I implore you to please reach out to us, reach out to Ross or myself or Steven even, and we'll be able to give you more information on that and even walk you through the environment to show you what it can and can't do.
Yeah.
next question is, how have other organizations handled drafters versus designers in transitioning to MBD as part of MBE? I sense that some concern from drafters on how this role is eliminated or changed.
Well, so I'm just going to give a quick anecdote. I had this conversation and discussed it many times with a former colleague of mine, Rich Eckenrode, that many of you may know or may not know. And he had a lot more experience he was significantly more aged in the field of industry and had a lot more experience with being able to understand the physical design versus the model-based design and the desires of those users. And one of the questions that always came up was, how do you take somebody that's used to being able to write anything down on the paper that they want and hand it to somebody else and tell them that they need to do that in a digital environment when they're so used to being able to, if something's wrong on the product floor, if there's a product that comes out and there's a tolerance that's wrong or something gets produced incorrectly, they could literally just walk up to the line, grab the drawing off the line, mark down the changes on the line, and then hang that paper back up. And that's the term that they would use, is called hanging paper, to make those changes there. Where with the digital environment, you're having to take those drawings and put them in this 3D environment and make them utilized by the model so that other people can get it and access that information from different terminals or in different ways. So in transition from 2D to 3D, there's a lot of training that goes into place to, one, understand the technology, but then two, understand that when you go from physical drawings to this technology, you're not actually limiting yourself. You're not actually taking away the ability to write in those notes, to write in those annotations, to make those changes on the fly. You're just doing it in a different way, and you're presenting that information to your users in a different way. Now, some organizations, and we saw earlier on one of the polls that a lot of the organizations that are with us today use both the model and the drawing. And that may be in the form of they do their designing in the design environment with 3D models, but then they print out different views of those drawings or different views of those models, and then they create those digital drawings and they print them out and they take them out to their designers. That may be one way that workflow is in place. Another way could be that they have terminals on the floor that the users are accessing, and so they're seeing this live updated model information, and they're actually feeding that model definition information into the machines to be able to run their inspections, to be able to run their productions. So there's different facets of how you're utilizing this information, but in terms of getting those 2D users to this 3D environment and getting them to understand the benefits that can work there, it's all about that slow transition. It's all about teaching them the benefits, showing them that their job is not going to be interrupted by changing to this new technology, and then showing them how they can do the things that they already do today in this new technology, and then providing them those benefits so that they can see not only how it's helping them do their job, but how it's helping other people in the organization do their job as well. So I know that was a lengthy, long-winded explanation there, and I would be happy to talk your ear off about it for hours and hours, but I'm just going to leave it at that.
And we have to move on to the next question.
Yeah.
Is the GD&T Advisor fully QIF in order to use in the downstream?
So in a manner of speaking, yes, in a way. This information that GD&T Advisor creates, I would look at this more as an authoring tool. So it's an opportunity for you to insert a lot of that information into the data with guidance. So in the same way that if you had manually inserted all that information directly in for this particular situation, Creo, and it would be available to you downstream if you had information that needed to pull from it. much the same with GD&T Advisor. It just for our particular tool helps make that process a lot more user friendly and a lot more guided to the standards that they need to adhere to. But I will say that, you know, part of the reason that GD&T Advisor exists is, again, because we have things that we've created that already belong downstream that will take that information and use it and make the user's life much easier. So it's a tool to help more people and better people and better improve how many people can get their hands in to get that information in accurately, early, so it's accessible completely downstream for everything else. Could you insert that into a QIF system that you guys have in place? Absolutely.
Thank you. So the next question is, hi all, I'm interested to hear if you have experience using MBE with other aspects of inspection, for example, non-dimensional, NDT, etc.
So when it comes to non-dimensional inspections, I have a little bit of limited information with being able to pull information out of, let's say, a machine on the floor like a CMM, being able to pull that information, those readouts from the model or from the part that you're inspecting, getting it back in. But when it comes to actually utilizing that MBE information outside of the annotation environment, outside of the MBD specific environment, I'm fairly limited. I don't know if Ross, you have anything else, or even Mark or Ray, if there's anything that you can offer for that as well.
I think that probably the best experience that I have for any of this would be anecdotally. I know that kind of tagging on a couple questions ago, I used to work for a place that we were kind of mid-transition between using, you know, paper as our master versus CAD and GD&T and everything as our master. And during that transition, there was a lot of back and forth. So I know that even when you do specific non-dimensional checking, if you've got, like, you know, go, no go, or whatever else you've got going on that you have feedback, somewhere in the process, a lot of times you can insert that information back into the system. So if you're getting unexpected results for things, that may be an opportunity to reintroduce that new information that may have come from non-dimensional inspection, to realize that, okay, we've got a problem earlier in the stream that we can go back and address. Then that's information that you didn't have when you originally arrived at that part of the stream going forward in the design process. So
right.
that's about the best anecdote that I've got in my personal experience for it.
And going on top of that question, also on top of inspection PMI, do you see much on model-based manufacturing, welding PMI, for example?
When it comes to welding PMI, I guess that would be, Ross, that would be more of a you question when it comes to the utilization of are we talking about the utilization of our software for welding PMI and getting that information in the system, or are we talking about just our basic understanding as a whole? Because I can tell you that welding PMI definitely has a place in MBD, but if we're talking about usage for the software, that's probably a Ross question.
I think it was leading towards the software.
Okay.
Yeah, for the software specifically, if there are particular callouts or anything that you would want to insert, you know, customization of callouts either here or in some of our personal other products or in your CAD software in general would be available. But if it's a notation that's inserted correctly into your information, I don't see why it would not be relevant and carry with the rest of your data going forward. I know from a manufacturing perspective, even if you're not welding specific, if you're doing CNC or some other production level thing there that has mechanized manufacturing, that could definitely be of use as well.
And the last question I have is GD&T Advisor. Is it coming as an add-on in Creo or coming default with each version of Creo? Otherwise, stated a separate license is needed for GD&T Advisor. So it's a question about, I guess, your module.
I'll give you guys a quick snippet, and then I'll just throw this out there. If you guys have specific questions about GD&T, feel free to reach out to me directly. I'd be happy to field them. I just don't want to bogart the entire call handling the sales questions for our Sigmetrix products. But yes, it's an add-on that we've created that when installed is integrated with Creo. It is a separate license. It does not come with Creo. But hey, if you'd like some more information, give me a call. I'll be happy to chat about it.
And one last question just came through. It was to the one about the weld. It said weld, not specific to software, more generally people using PMI for manufacturing. Do you have any experience with that?
Yes, I specifically do. I can tell you, and this is probably anecdotally as well for me, I've worked multiple different internships and jobs, and one job that I had was working on the manufacturing floor at a company called Group Deco, where we were doing manufacturing line assembly and then also stamps, dies, presses, retooling, and laser cutting. And when we're talking about being able to get that information off the floor back into the designer's hands, there were often times where we would have schematics come out, or we would have drawings come out, or even printouts of parts come out, where we're designing something, or we're pressing it in the machine, or we're assembling it on the assembly line using a series of parts that were printed or given for us, or even cut out from the sheet metal, where things wouldn't fit together properly, or things came out and they didn't look right. So then what do? You break out your calipers, you break out your measurement devices, you take those critical dimensions that aren't working, you take those measurements of what you have, and then you take a part that passed, and this goes back to Ross's go, no go. If it passed, you can take some inspections from there, see how much it was off by, and then you report that information back to your design team. So you're taking that manual inspection information off the floor and getting it back into your design environment. And that would work for welds and everything as well. You know, if you're doing bends and then you're welding parts together and then more bends to be able to get your shaped design or your shaped metal, you would take those measurements as well. So it definitely has a place in the environment, or a place in MBD.
Thank you. Ross, could you bring up, that actually concludes our questions. I want to thank Jesse and Ross for presenting today. Just remind everybody who's attending that next month our coffee chat will be closing the skill labor gap with QIF. That'll be by Origin International, Jeff Fowl. And again, you can register. Registration is now open. If you go to the QIFstandards.org to events, you can find it on October 26th. So please, if this is an interesting subject, please sign up now. We'd love to have you come in. And this concludes today's presentation. I want to again once again thank Ross and Jesse for doing a great job. And I think the audience, great questions. We thank you for your good and challenging questions. Everybody have a great day, and this concludes the meeting.
Thank you, everybody.
Thanks.